Hey guys, welcome to my channel. I don't know how you got here, but I do hope that you'll stay until the end of this video because in this particular video, we're going to talk about making schematic diagrams. Now, what exactly are schematic diagrams? Basically, they are more defined drawings that are presented in a simple manner, okay? So, I don't know if you've ever seen a floor plan, an architectural floor plan or working drawings, but they are actually quite complicated. And we kind of use the schematic diagrams to simplify things for us because there are a lot of mistakes that can be avoided when we kind of break it down first. So through the schematic diagram, we already have like an idea of where everything is going and how everything can flow. And we can already start asking ourselves, well, what about this? What about that? How do we solve how do we solve this problem? So that is the importance of making a schematic diagram, at least for me. So last in my last video, I talked about how to make a bubble diagram. So let's go ahead and bring that up. That's a bit rough. Let's try that again. There we go. All right. So so I cleaned it up a bit. Um, I mentioned before that bubble diagrams are freehand drawings, and a lot of people may argue that wouldn't it be easier to do it using computer aided software? And yeah, it would be easier, but we're not trying to make it easier. What we're trying to do is we're trying to make it more uh, of a project that we are passionate about. And when you use computer aided software, you tend to be restricted from things. Whereas if you do a freehand drawing, you kind of let your imagination just run wild. And that's kind of what we need. We need to have that balance of imagination and reality. And in the case of the schematic diagram, so we're going to translate the bubble diagram into a schematic diagram. And this is where reality kind of bites us in the ass, okay? So of course we also have to work with our matrix diagrams and our computation tables. But since we didn't do all of that properly, we're just gonna kind of go on the fly here. So of course, this is an imaginary two-story house, so we have an imaginary lot. So that's 15 meters by 20 meters, 15 meters wide by 20 meters deep. Okay, so how do you go about starting the schematic diagram of uh, the site? Okay, there's kind of we're gonna break this down a bit. Okay, there's the schematic diagram of this site, and then there's the schematic diagram of the buildings. Um, as before, you'd always start from macro to micro. So let's go ahead and start with the site. One of the important things to start with is the setback because we need to get a better idea of the building footprint. So we should start removing the setback um, from our building. So the setback is basically the distance of the wall from the property line, the exterior wall from the property line. You can refer to the building code in order to get the the proper distances. But in this case, we're going to have the frontage be 4.5 meters and the sides and the rear be 2 meters. So there. When working with schematic diagrams, you should also work with the most basic shapes. Don't try to, don't think that you're amazing enough to just like work with like whatever forms you want. Um, Start with simple shapes and then work your way into those forms. Okay, so as you can see here, our actual building has just gotten smaller. Mm. So reality is already hurting us. Um, Next thing we can do is we can work with the spaces around, and it's really up to you which one you want to work with first. Um, I kind of want to start with the more detached areas. And as from looking at the bubble diagram, we can see that the gazebo is like kind of the most detached from everything. And since you know, I didn't make a computation table for these areas, I'm just going to base them on the my knowledge of a proper space for these areas. And I'm going to say that a gazebo can be, so we're going to have a circular gazebo with a diameter of 3 meters. I feel that's a fair size. Okay. And a gazebo is not an enclosed space, so it doesn't necessarily have to follow the rules of the setback. So we're gonna put it like 1 meter away from the property line. Okay. So when we work with schematic diagrams, we're usually working with addition and subtraction. There's not much multiplying and dividing going on. Not yet, anyway. But when you're doing it in the most basic sense, it's mostly just adding and subtracting. So the first thing you notice is that our gazebo intersects with our house, which means that we're going to take away space from our house. There. 3 meters seems fair. So that makes our gazebo roughly 1 meter away from the exterior wall of the house. Next thing I'm gonna do is, let's see, let's do the parking, okay? So since schematic diagrams are pretty self-explanatory, um, I'm gonna kind of give tips every now and then on how I would approach projects. Um, we're gonna make the garage 6 by 6 meters, so that's for 2 cars. The parking is 6 by 6, and it's also not an enclosed space. Okay, which means that it doesn't have to follow the rules of the setbacks. However, I don't want to keep it here on the side of the wall. Why? Because it's still a roofed space. So our garage is roofed, and that means there's a possibility that water will overrun into the neighbor's yard. Or worse, if they have a firewall, it will overrun into their house. So we don't want that. We want to be as ethical as possible, okay? And I personally don't want to work with a firewall as much as possible. If you can avoid using firewalls, I would advise, try doing it. But we're gonna go ahead and set this back 1 meter as well. And also in the frontage, we'll set it back 1 meter so that we have kind of a dynamic. So once again, our house has intersected with another area, which means more subtracting. This time, let's just subtract this area. Okay, there we go. Okay, next we have a front porch. Let's make that 2 by 2 meters. I don't expect people to hang around in the porch. I just expect them to kind of like knock on the door, ring the doorbell, and expect them to be greeted inside within the next 10 minutes. Because I might be on the toilet and it might take me a while to get there. So, okay. Then we have the terrace. We want to let's say we want to have an outdoor dining set on the terrace. So let's go ahead and make that. Let's see here. How big can we make it? Let's make it 3 meters by 5 meters. That sounds decent enough if you ask me. Okay. And then we're just working with basic shapes, all right? So there we go. As much as possible, you know, we want to make it realistically, possible. However, we don't want to stray too much from what we have in our mind, what the design that we want to achieve. Excuse me. So, uh, we're trying to conserve space at the same time, be generous with space. Yeah, it's contradicting, I know, but we can do it, guys. We can do it. So next we have a pool on the left side, but we only have 2 meters here. So let's go ahead and move the terrace 2.5 meters. Okay, and then let's move this 2.5 meters as well. So now we have space for the pool, but as you can see in our bubble diagram, the house and the pool, the home and the pool are in indirect contact with each other. And you can kind of tell that because I used more transparent arrows. So let's kind of have like let's have a space here of 1 meter. Okay, and the pool is in direct contact with the terrace, so we'll and the porch. So let's connect those two like that. And let's say something like this. Let's go ahead and set it back all the way to the walls, just like that. Okay, bam. So we have a very giant pool now. Okay, the front, perhaps we can move it back to where the porch is, right around there. Because we have here on the bubble diagram, we have a garden here in the front, and then here we have a garden in the back. Then, so how wide is this pool? 3.5. Let's kind of make space for some vegetation on the sides. And let's go ahead and go with zero point 0.5 meters away from that property line. So since it's not an enclosed area, we don't have to worry about setbacks. Okay. Now, as I said, I'm going to kind of give you kind of tips and pointers while we go about this. And one of the things I want to point out is, so like I made this pool here in this area. Of course, the pool is going to take up space, and it's not only going to take up horizontal space, but it will also take up vertical space because you have to dig the depth of the pool. In this sense, we can already start imagining like how will certain things go under it, like where can we place the septic tanks, where can the pipes run through, things like that. So uh, with these kind of things, with things like swimming pools, especially, you should consider those items because in the long run, let's say this is actually a very small project, despite having a generous lot for the Philippines, but in other projects, there are times like, for example, if you didn't take into consideration that the power pole is going to be on this side, then how are you going to connect the electricity into the house? You have to like run it here and then here, so it takes, you have to make sure that the water doesn't penetrate into that area. It's not really a difficult task, but I'm just pointing out like there are things that will arise that you have to solve the answer for. Um, it's not I one project I'm working on currently at this time uh, that I didn't take into consideration while I was working on it because I didn't have all the information. But fortunately, I was still in the schematic diagram phase. Was the power pole was actually in front of the garage. So it's not just a swimming pool, but like these kind of things pop up. So the power pole was in front of the garage. And why is that a big deal? Because cars have to come in and out. And if the power pole is right there, it kind of makes it a bit difficult. So that's like one of the things. Since I was working on the schematic phase already, I was able to anticipate these kind of things. I was able to ask these kind of questions, and I was able to find something wrong with what I did, what I had planned, and I was able to adjust way before I already started making the construction drawings. So that's just like one tip I'd like to throw in there. All right. Okay. So anyway, so this is like a general layout of what our uh, proposed two-story house is going to end up like in terms of the site. We have the parking, we have the house, we have the front porch, we have the back terrace, we have the gazebo, we have the swimming pool, and we have the garden spaces. So we've pretty much accomplished fitting everything in there. Okay. So like I said, we didn't really work on a computation table thoroughly. So I'm just kind of working with spaces that I know will work, or dimensions that I know will work. And also another thing is don't think that just because, like I said, we're working with basic shapes because we're trying to figure out how to put everything into our lot. We're trying to organize it in a way that is understandable for, people that don't know how to read floor plans. And it's also understandable in a way for us before we start creating the floor plan, such that we can already start asking ourselves questions before the problem arises. So don't think that just because you use basic shapes that this is how it's going to turn out. It's going to be all squares and rectangles and a circle. No. Once you start working on the actual working drawings and architectural drawings, you can start defining the shapes better. So like here we can make the pool more round edges, and then we can make the parking a bit more designed like because you're probably thinking that this is just a wall, but maybe we can like add vertical stilts on the side instead, stuff like that. So don't think that just because this is how, just because it looks simple, it's going to come out simple. That's not how it is. We're just making it simple. That way, we're going through a process that we're going to make everything more and more defined as we move along through our project. Okay? So don't be afraid. Don't be afraid, and don't think that this is how it's going to be end up being. Now let's go ahead and talk about the interior spaces. Another tip I'd like to point out is walls take up space. They take up so much space, you have no idea. How much space, you might be wondering? Well, let me tell you. I would say 15 to 20%. Why is that a big deal? Consider the following. You have made a room that's 2 by 3 meters, okay? 2 by 3 meters is 6 square meters. That's your space inside of that room. But you didn't consider the wall thicknesses, okay? The wall thicknesses, like I said, is if we're going to use the minimum, 15%. 15% of that room is going to be eaten by the walls. How much is 15%? 15% of 6 square meters is roughly zero point 0.9 square meters. So that's almost 1 square meter. Do you know how many things you can do with 1 square meter of space? So from 6 square meters, you're down to 5.1 square meters. Imagine that. Imagine that. All because you didn't consider the space of the wall. Why is this important in the schematic diagram? Because we're making everything simple. We're not using wall thicknesses. We're not using difficult forms or anything. We're making everything as simple as possible. But as early as the schematic phase, always consider that there is 15 to 20% of space taken up by the walls. Okay. Second tip I'm going to give you guys is that stairs also take up space. And the thing about stairs that's tricky is they don't only take up space on a horizontal sense, they also take up space on a vertical sense. A lot of times, you might see like memes where in the floor plan, the stairs are like, going that way. And then it turns out there wasn't a landing, or sometimes the stairs, you'll have the stairs and then you'll have something underneath the stairs, but it's at the lowest point of the stairs, so it makes what you created unaccessible. So always think of stairs in both horizontal and vertical sense. So I'll give you an example right now. Um, so typically, since this is kind of a small space, I want to have my steps be 900.9 meters wide, and then I want them to be 30 centimeters deep. Okay, so this is our basic step. Okay, now thinking in a vertical sense, uh, I would advise that the rise is the height of a step, the run is the depth of a step. Uh, Me personally, I would advise that the rise would always be between 15 to 18 centimeters if you want it to be easy on the knees, okay? Um, there are some, there's a lot of areas here in the Philippines that also go beyond that, sometimes going as far as 25 centimeters. There's a lot of European nations that also have narrow stairs and high steps. And yeah, it's all good. It all depends on how you want to design it. But if we're just gonna for this particular design, let's try to stick with that. Now, we want to be comfortable. Like we have two parents that are getting a bit old, and we have some kids running around the house, so we want it to be safe for everybody. So let's say that it is point 15, let's say it's 15 centimeters high. Now, when we think in the vertical sense, we want the clear head space to be roughly 2.7 meters. So from finished floor line to finished ceiling line. Um, and let's say that from finished floor line to finished floor line, so first floor to second floor, we want it to be 3 meters high. So how many steps is that? Let's do the math. 0.15 times 20 equals 3 meters high. Excuse me. So that means we need 20 steps. Bam, 20 steps. That's how much space 20 steps takes up. Okay, so in order to like avoid this, we don't want it to have it like straight. We have to have breaks within the steps. So we have to consider that there has to be some landing somewhere. And then we have to consider like the way the steps are going to go up. Are they going to form a U? Are they going to form an L? Are they going to be straight? That's up to you as a designer. It's really is. Most people though tend to make a U from my experience. This is all just based on my experience, but you know, you may have your experience may have differed, but whatever. Okay. And let's say they want, okay, we're just kind of working in the hypothetical right now, okay? Let's say that they want it to be like that. They want the living room here. So we have the entry, the foyer, dining area, kitchen in the back, and then we have the living area here, and this is where our steps start. Okay. Do you know what's wrong already? That's not the proper way to set up the stairs. Why? Because there's no landing. How are they gonna turn here? I know it sounds silly, but you wouldn't believe how many times I've encountered this situation, and it's always funny when I see it. So that's what I was talking about. Like you've seen those. I'm pretty sure you probably if you're into like design and stuff. I'm pretty sure in some point in your life you saw that meme where the stair goes right into the wall and then up. That is a common mistake. I'm not joking. Like sometimes it's only found during the floor when the floor plan is already made. It's like, wait a minute. Remember, there should be a landing. Never ever forget that. Let's make the landing just a perfect square. Okay. Next, always, always, always count the steps. Recount them, recount them, recount them. Recount them at least 5 times because I swear sometimes like an additional 2 steps come out of nowhere or additional 5 steps come out of nowhere and you don't know how it got there, but you can avoid this problem so easily by simply counting the steps. So let's count them, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and then 21. An additional step came out of nowhere. You see what I'm talking about? And that's because we're only working with basic shapes, you know. Always count them. So an easy way to rectify that problem, we can just transform the landing, make it into one giant step. Bam, problem solved. Simple, right? Okay. Next thing, when considering the stairs. So like I mentioned earlier, a lot of times, because this usually happens to people, like I've noticed this, like they just go directly into the floor plan. They skip over this whole phase just because they feel overconfident or they feel so confident that they're not gonna make a mistake. Toilet and bathroom, they put it right here underneath. The reason they put it right in this particular spot is because they want to give it a window. But remember, the height of each step is roughly 15 centimeters. How many steps is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So from the ground to this landing, the finished floor line to this landing is roughly 1.5 meters. I'm going to say this again. Walls take up space, okay? But so do supports. Slabs posts, columns, beams, they all take up space. So even if we're going to be generous and say, okay, maybe if he crouches down, if the person crouches down and they go inside, they can probably use the toilet. Possible. But we also have to consider the thickness that's supporting this step. So let's say the thickness is another 15 centimeters. So 15 centimeters deducted from your already low 1.5 centimeter powder room, which makes it 1.35 meters. Yeah, I don't think you can crouch that low. So in theory, it's a great idea, but don't rush into it. You have to really think about it first. So let's say we turn this 90 degrees. Bam. Let's say you put it here. Wait, where am I going? Meh, 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 meh. Say you put it here. 5 meters. Okay, you rearrange the house. This is the living room. This is the kitchen. This is the dining room. Okay, that's the rearrangement. And then this is the highest point of the stairs. So this is where you go up the stairs. This is the highest point. Now you have space for a toilet underneath. Okay. Another thing you have to consider though is the second floor. So this is why schematic diagrams is it's very helpful, man. I'm telling you, don't skip don't skip steps just because you feel like, unless you're copying a design from the past, then or you're copying a design from someone else that you saw work, then don't skip it. The reason I'm saying that you should consider the second floor is because now sometimes I've also witnessed this. People will put a room right here. Remember that this is the very top. In the second floor, this is the very top landing. And if you cover this portion, the height from this landing to the second floor is going to be 1.5 meters. Because why? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Another 10 steps. So as they go up, they are not going to have any more space. Even if you were to move this line here to this side and make that the room, you're still on the landing. Don't make these mistakes, please. I'm just, as much as possible, I want to instill it in your guys' mind. I want it to be imprinted in your minds, not to make these mistakes. That way you can become better and better and better. And by, catching these mistakes early in your career or early in your passion into design, at least you can do something amazing. Okay, it's not the big things that matter. If you look at buildings that lasted throughout, the test of time, it's not the skyscrapers, because skyscrapers, yeah, they're big, but the only thing they achieve is being big. They're not really remembered. Like you don't really think about it and you don't like have a fond memory like, man, I wish I could go back there. But it's usually these smaller spaces that like you have more fonder memories of just because of the smallest things about them. And that's kind of what you should think about as, if you want to be an architect or if you are an architect and you're trying to figure out what kind of architect you want to be, you should kind of understand what do you want to contribute in the world into the world, the landscape of architecture. If you want to contribute tall buildings, that's fine. You know, you should still start with schematic diagrams. Why? Because the elevators, the stairs, all of those things, you have to understand how they all work. If you just want to make houses, that's also fine. You know, still should consider starting with a schematic diagram because you want to make sure that this family is able to live their life in this house hassle-free without being stressed out over every single thing that went wrong because they're going to spend their life in this house. If you want to design like commercial buildings, that's fine as well. Start with a schematic diagram. understand how the people move, how the people flow, and then apply that in ways that will work, like in ways that people can fit. Because it's hard, it's so easy to point out mistakes. It really is. It's harder to point out the things that people do right, and it kind of sucks because as a person that like you want to make everything correct, but people are going to always find the mistakes in things. The best thing that you can do is even if they point out even if they point out little mistakes, the best thing you can hope for is that when you create something, the experience is something to remember because of how amazing it was. Okay. And, you know, amazing experiences can be good or bad. So remember that also. So if it was a bad experience, your building will be remembered as that bad experience. If it was a great experience, a good experience, one that made them feel good, then that's really going to be, what you want to achieve. And it's through those kind of like little experiences, that's what kind of makes architecture stand the test of time. It's not like how high it is, it's not how big it is, it's not how, grandeur it is, it's not how expensive it is. You can have, I've seen houses that are so expensive, like so overpriced simply because of the materials and, the person behind it. But when you go inside it, you don't, it feels so empty. But just by doing these small things, like taking into consideration how these things work, then you can actually do more. All right. Anyway, I'm sorry that I'm kind of going into this this kind of dramatic territory, but yeah, it's really about, this. The only reason I do these things is so I can help people that are kind of trying to figure things out. Because a lot of times, also, when you ask yourself too many questions, you don't really get anywhere because you're trying to solve them all. Start with a schematic diagram. All of your questions start getting solved one by one. Like ask them one by one, and eventually you'll solve every one of them. Eventually, some of your answers will clash with another answer, but you'll figure that out in the schematic diagram, and you can figure out a way how to make it all work in harmony. You know. Anyway, yeah. Sorry about going into that tangent. I'm really passionate about designing. I really love designing. I really enjoy designing things. Even if I don't have clients, even if I just design things on my free time, I love doing it. And I'd like people to have the same experiences that I have when I'm doing these kind of things, like how much passion to feel about it. But anyway, we're gonna end that here since I'm already going longer than I expected to, and unfortunately, I also have a job. Ouch! I'm not rich, guys. But take care, everybody. I hope we can always better ourselves, and bye bye.